Okay, we still have more people rolling in, but I don't want to make those who are on time wait too much longer. So I think we can get started. Welcome everyone to our persistence module Q&A. This is one of four components of our V1 spec. Yeah, we've already so far had an overview of V1, a Q&A about the utility module, and now we're looking at persistence. The format of the call will be we'll provide, Louise and Irving will provide an overview of the persistence module. Uh, I think maybe we should start with just explaining what persistence is, what the persistence module does, just at a high level. Then we can cover how persistence works in V0, and then move from there to how persistence works in V1. And at that point, as we're going through each of the specific PCs, we can pause for questions. And then obviously we'll have a Q&A at the end. If you do have any questions, just press the raise hand button in your Discord app, or we also have questions coming in from Twitter Spaces. If you prefer to type rather than speak, you can also use the V1 research channel in Discord to ask your questions, and I'll make sure that they get surfaced to the folks here on the panel. So without any further ado, let's get started. Louise, what is persistence?
Awesome. Thank you. Thank you, Jack. That's a great introductory question. So persistence basically means to persist. Basically, data that is running in a process is in memory and needs to be persisted throughout multiple executions of that process. So if you start your Pocket node and then you have to shut it down for maintenance or whatever, you don't want to restart all the blockchain data from scratch. You want it to be there so you can start where you left off and just sync the difference when you're coming back up. So the persistence module in Pocket and in any blockchain client or most of the blockchain clients allows these clients to store data permanently and access it every time they do an operation, so they can verify a block. They can a validator can position themselves to participate in consensus and so on. So this module fundamentally is the data backbone of a blockchain application.
That's helpful, thanks. And how does the persistence module work in Visio?
So let's start there. Yeah. So currently we are using a pretty standard model, specifically with our. So you can think about a blockchain persistence in two realms. There is data that the application needs to persist for operations that is outside of the state, and then there's a state and block data. The difference here is that the part that makes blockchains so useful is that this state data and this block data can be verified. So you need a specific set of metadata to in your database to basically be able to verify or prove to others that you have the correct data and you're able to participate in the blockchain network. So the way it works today in B0 is that we have this combination of the two. We have certain databases in the application uh, that are used for different parts of the application outside of consensus and block syncing. One such example that might be known to node runners is the Pocket Evidence DB, which is a database that stores relay evidence, but it's data that only the current service node holds. The rest of the network doesn't need to know that data, but it's needed for that node to later submit their claim and proofs to be able to get paid for the work that they did. So that is one example of non-state, non-consensus related data. And then there's a state data. What is the state? Every time a new a transaction gets submitted, you can basically think about it as a new version of the state. The sum of all the state transitions that happen in a block on every transaction are basically the new version of the state. So every new block, you have a new version of the state, and the state is basically what the word means. Is the current set of data of what the latest consensus the validators agreed upon. So what are the latest balances? What is the current state of claim and proofs? What are the latest governance params? What are the latest staked apps and staked nodes? So all of that, all of those are versions of a state. And every one of these versions has to be stored in the database for whenever an operation needs to go into the past, for example. If you want to do a claim and proof life cycle, you need to be able to look at the data a few versions back in order to be able to determine which proof you want to correctly send so you can get paid. All of this happens automatically to the node, but this is a sum of things that ends up being a good chunk of the processing that the node does. Another important thing here is state validation. Whenever a validator has to validate the next block, they have to replay the transactions that they're sent in the proposal block against their last known version of the state. And if a single byte here is different, you're gonna be totally out of whack and out of consensus. So the state is one of the most important pieces in keeping a blockchain functional.
Okay, that was helpful. Thanks. And in V0, we're using a key value file system, right?
That is correct, Jack. And let me tell you something else. Something that is not so standard in modern web applications is using file databases. And mind you, all database engines use files in the end to store the data, but it is like at the scale of at the level of scale that needs to be reached by the pocket nodes and things like that, uh, this choice represents a box in which you have to fit in. It makes the data more portable because the data is right there with the process. It's of easy access because it's basically an input output call to the disk. But at the same time, it creates bottlenecks in other areas that might be necessary for the node. So, for example, right now, all of our databases, regardless of whether they're state or not state related, are a key value in a key value schema, meaning every every piece of data has to be schematized in such a way that all the database knows in the file is that if for a certain key you're gonna get a blob of bytes, and whenever the application needs to read something, it will have to take search for that key, get the key, get the key value, and then extract those bytes, and then decode those bytes into a structure that the application understands so that it can apply its process. So in this set of things, you can start to think about a few constraints. For example, one question that we've gotten in the past is why can't different nodes that are just servicing relays access the same blockchain data? Why does every node need to be a, it hold its own copy of the database? And the answer is this: because of this design choice of using file system DBs, and then on top of that, a this is a key value versus schematized databases. It really depends on the use case and the data that the structure that you are persisting. But there is one particular thing with state, and the thing is, every state version that I mentioned before, from block 1 to block 50,000 and over, um, is a tree, a Merkle tree. And what that allows you to do is that it allows you to compute a new hash for the new version of the state that is the hash that validators come into consensus for. So to put that in simpler terms, you have to not only store the data that is already in the state, meaning the list of balances, the list of accounts, state applications, and things like that. You also have to store all the nodes of the tree all the way up to the top, uh, which makes it have a little bit of overhead. It's very efficient for uh, computing changes into the state, but it can be very inefficient when you're thinking about state retrieval. Imagine someone trying to query the list of nodes currently in the network, which right now totals to 35,000. You have to first go to the height that you want to query the list for, and then get the list from there. So it starts becoming both in the space realm a little bit untenable, and on the performance side as well. So, but that is how it works right now, because we inherit this design from the Tendermint Cosmos stack. And truth be told, most blockchain clients work like this. It's a very common design nowadays.
Yeah, I think it would be helpful to, at a high level, sort of summarize the key drawbacks of the way things are done in V0. As I understand it, um, we have issues with data duplication from block to block. We are bottlenecked by the I/O. And is there anything else that we can highlight as well? One, if we've not fleshed those out, it might be helpful to do so. But I also wonder if there's any other drawbacks that are worth highlighting for the current VZO model.
Yeah, things we've seen in the past go all the way up from what you just mentioned to data corruption, meaning anything in the process, if you held back, there's a combination of factors here. If something happens wrong in the process and you write the wrong byte to the database, now you have an irrecoverable database. And on the other side, not irrecoverable, but very hard to recover database that usually takes less time to just grab a fresh copy than trying to recover it. And on the other side, you also get, as you said, bottlenecks on the I/O, and also bottlenecks on general lookup and scan performance. So usually, how a database works is that you have a set of data and you have to scan that data and then do a lookup algorithm on that data to get exactly the piece of data that you need. So what ends up happening is that in the current model, for example, whenever we are processing a block, uh, we are having to do several lookups into this database that has duplicated information for the sake of uh, uh, for example, in the case of the state, for the sake of that easy computation of the next state hash, we have a lot of duplicated data that adds overhead on every lookup. So every time a validator is checking a transaction, it has to go to, let me see the balance of this account in this height. Does that balance is higher than what he's trying to transfer, and so on and so forth. And then I have to look up the other account. I have to sum the two values and set the new value for that other account. So all of those operations, every time I have to scan and look up in the database, uh, it adds a little bit of overhead. It's like death by a thousand cuts. So that's one of the primary ones. Another one that is interesting about the especially key value storage, is that key value storage can be very useful for arbitrary byte storage, meaning in cases like Ethereum, you can have people uploading arbitrary bytes in the form of a smart contract that now you have to store in the state. And you need to be able to look up these bytes, pre-process them, package them into the smart contract bytecode, quote unquote, and have the EVM process it. Whereas in the case of Pocket, we don't have such a need. We already know how every piece of data is going to look like. So we basically have a pre-schematized database, but we're fitting it into the key value mold because this is what we inherited from Tendermint. So in that particular case, it's not the best tool for the job approach. It's very helpful for certain approaches, but it might not be the most helpful for our current data needs.
So yeah, I think now that we kind of have a really good grasp of what the limitations of V0 are, that walkthrough was really helpful for me, and I imagine everyone else, in terms of understanding the impact of the persistence module on the efficiency of the chain as a whole, of all the processes that are performed. I think that leads us nicely on to talking about V1 and um, where the new direction that we're heading in with V1 and how that fixes these challenges that we've outlined here. So
Yeah,
perhaps you can start sort of with an overview of the design philosophy behind V1.
yeah, exactly. That's where I was going. So B1 asks a very interesting question on every design decision so far. And the same question is repeated all throughout every spec, and it's been repeated throughout the first steps in implementing B1. And it's what is the best tool for the job? What is the best for Pocket Network? Not what is the best for blockchain, what is the best for a decentralized network. It's a very specific question. What is the best tool for X problem in Pocket Network? And the persistence spec follows this same philosophy. It's how can we leverage the design space that we're at in Pocket Network B1 to basically get the best tool for every problem and get the correct trade-offs, because every decision is going to come with a trade-off. If you're going to get better performance, you might get more memory usage or more storage usage, and this adjusting these kind of trilemmas is basically the life of a software engineer. So having said that, the persistence module aims to answer a series of requirements, and this is the first one of the first sections in the spec. And these requirements basically mean what does a Pocket Network node need to operate on the most efficient possible, given the work that it's gonna do. And I'm not gonna read them outright, but these requirements are grouped in three pillars. One of it is having a client server architecture, meaning decoupling the app from the database, which is a very normal, not normal, but like a very industry standard design of highly scalable web applications, is separating the data source from the application doing the processing. The second pillar of this is the persistence client middleware, which is basically the code that is going to live in V1 client that is going to manage the relationship app needs in terms of data and what the database engine expects to be able to perform the data work. So in that particular regard, what it ends up being is the actual custom software that is going to have all the rules for how these data interactions happen, what binds everything together. And then you have the blockchain state validation architecture, which is how do we build a blockchain out of this persistent data set? Because in the end, a blockchain is a data structure. And what we need to do is basically have a persistence architecture in general that accommodates that data structure and allows that data structure to perform and thrive under the conditions that it's at, while maintaining all the same safety and performance uh, uh, attributes that we've come to expect out of blockchains over the years. So, having said that, those three categories basically make up the attributes that are required of the persistence module to come in and be able to fulfill the data needs of every pocket network node that is going to be in production in V1.
I think it would be in the interest of trying to provide a structure that listeners can ask questions in. I think it would be useful now that we've you provided an overview of the different categories of V1 to go through each of them one by one, uh, provide a detailed explanation of what those are, and then maybe at the end of that we can pause for questions. So perhaps we can start with explaining the persistence client middleware and how we envision that working.
Sure. If you don't mind, I would like to the client server architecture because I feel like it flows
Yeah,
better
sure.
with the with how these pillars work. So the
Yep.
clients are sorry. Go ahead.
No, I was just saying, yeah, as long as we're going through each component one by one, that's fine by me.
Perfect. Awesome. So the client server architecture allows that decoupling of the process of the node and a database engine, which is another process. But a database engine is an agnostic database that any application can talk to write and read data from. So having a client server architecture in the case of V1 is going to allow for certain things that V0 is not capable. Right now, we are bound to having a one node identity process living at the same time in the network. Let me rephrase that. You can only be running one process with the same identity, and that process cannot be horizontally scaled. What does horizontality mean? It means that instead of being able to scale your node by having multiple machines running one process each and them accessing a single shared data source, every node, because each data source is a pegged to each node because it's a file-based database that has to exist in the same machine that the process is running. You don't get to have that horizontal scalability. Every node is individually unique. And even if that's a desired property, in the specific case of Pocket, you get the case of servicers, for example, where with enough traffic, a single process application could drown. So what web applications have done over the last 20 years is basically create horizontally scalable middlewares. And what these middlewares are is basically say, this is an application that configured in a particular in the same way as the next application right by it, and all connected to the same shared data. They can perform the work independently of which process is doing it. Like for example, imagine being able to have a single node spread across three machines, and every time a relay comes through, any one of those three nodes is able to service the relay. What that does is that now you have the infrastructural capacity to service more work, and thus creating horizontal scalability at the individual node level. Another thing that this allows to do is basically remove the need for this removes the need to have that per one copy of the blockchain per node in the case of servicing, for example. In the case of servicing, you could have an architecture that will allow a full node to write the new block data as it comes by, and have thousands of servicers with different identities in the network share the same data pool and be able to perform work on top of that data pool. That changes node running economics totally, and it's one of the main core components of the new persistence spec. Uh, Another thing that is very interesting here is you don't have to run this engine on the same machine that the the nodes are running. Meaning now you can have a separate infrastructural component running potentially multiple horizontal copies of the same database so that you don't have a vertical bottleneck of IO like we see today whenever we're trying to access files in a single process. Go ahead,
There's something else that is a consequence of this, which is if anybody wants to develop specific kind of tooling for any reason in order to get information from a Pocket network, they can, and if they're running their node, they don't even have to really bombard their own node with queries for information. They could beef up their instance of data storage and basically use that as a source for additional auxiliary applications that allow them to have more information about the network for decision making or building dashboards or anything you might want to do.
Yeah, yeah, that's a very good consideration. And on top of that, this separation also creates a way of better handling your infrastructure because the visibility tooling that you can have on your database engine can be separate from the visibility tooling that you have on your node. Meaning now you have eyes on everything that is going up on and your application in a very specific way, which allows your automation and orchestration to happen in a more fluent manner. The only thing that is worth highlighting here is that this comes with a trade-off, as everything does, as I mentioned earlier, and it's the fact that the error handling becomes a little bit more complex because now that you have a separate infrastructural component running at the database engine, and now you have an application, you could have individual failures. You could have your database engine failing, and the process is still ongoing, or the other way around, where the process dies and the database engine is totally okay. But these are problems that are already solved for. We're basically bringing the best industry practices from already scalable web applications into the world of blockchain and decentralized infrastructure by saying, now you will have the ability to implement all of these best practices of treating your infrastructure as cattle, meaning if a node gets sick, you won't think twice about cutting it off and spinning a new one because the spin up cost is going to be so low that you won't be able you don't want to be dealing with each individual node to that extent. And on the side of the database, there are several techniques like streaming replication, backup automation, and management and orchestration software for database engines that have been in production for years and years that can be leveraged now for node runners in order for them to tweak their operation to their most preferred liking, and thus unlocking the true power of node running flexibility. So before I continue with the follow uh, pillar of the spec, can we? I want to open the floor for questions. If anyone has any questions regarding the client server architecture in V1.
If you do have questions and you're in Discord, just hit the hand button at the bottom of your. Yep, we've got one coming in already. And also, you can use the V1 research channel to type your question, and I'll make sure to surface it. Okay, we've got a question here. Lubo Vimo.
Hi. Very basic question. I just want to double check if I understood it correctly. Right now, when I do backup of databases, I cannot backup database of one node and then, for example, take second node and try to kind of like override or ignore the files that I already have, for example, on cloud, and just add the files that are missing. That would corrupt my database. So in V1, can I do this? Can I basically use any node as as an updating my cloud backup?
That is correct. That is exactly correct. And not only that, in real time, you will be able to one or a series of nodes to basically serve as the writers to the database and another set of to serve as the readers of the database, which will allow you to mix and match your setup however you like.
So and even beyond that, since we are going to be using specific self-contained solutions, like actual database servers are going to be part of the infrastructure. That means that the possibilities are even further than that, because you can use the facilities that the database servers themselves make available for different ways of backing up and replicating and providing high availability. So those things are going to be available in V1.
Sorry, so just to clarify, would it make possible to use one database, for example, storage somewhere, and connect to it more nodes, or just as reading the database? So like, for example, not to replicate the database for every node, but have, for example, like 10 nodes that will read one database and these kind of clusters.
Yes, that will be possible.
Awesome, thank you.
Thanks for your question. I'll move you back to the audience now and see if anyone else has questions.
Yeah, I got a question. So Luis, you mentioned a use case that I never really thought of, and in the V1 docs, you give a figure 2, which kind of lays out the different ways that people compare nodes with the database. And you mentioned this one where you have multiple nodes that essentially have the same identity. So I deploy my Pocket Validator, but then I can essentially have multiple of that same Pocket Validator on I guess like different machines or something like that. What would that are all then pointing to the same database? I guess I'm not sure what the use case of multiplying your same validator would do. What would the benefits, or what are the use cases for that versus just having separate validators? Because I can definitely understand having separate validators all using the same database, but why would you want to duplicate a existing validator into multiple like instances?
So that's an excellent question. Remember that are different actors in V1, and we're making a clearer move into more defined actors. When you say validators, do you mean validators coming into consensus to validate the chain, or are you also talking about servicers like we have it today in V0?
Well, in V0, my understanding with V1 is we're not going to have a distinction between servicers and validators. That was
No, we will. In V1, we will. Yes.
Oh, we will. Oh, okay.
Yeah. Yes, correct. So the validator set, of course, is going to be a per identity. One thing that, and again, it's still early days in development. One thing that that could happen here is that by having multiple horizontal validators validating the chain, you could have maybe in the future security features like having a consensus on one validator and being able to double check the data for data integrity purposes stuff, which is something that don't expect in the V1 launch, but these are possibilities that open with this kind of design. But the main reason why this is important is servicers. If you have if we reach a point we have so much traffic, but the node count is not expanding, each node is going to get more traffic. So what will end up happening is that these nodes could potentially get theoretically pounded with traffic and be very hard to maintain online. In that point in time, instead of scaling vertically and adding more hardware to the same node to keep it online, or having to resort to any other technique like process management and things like this, you can basically go to the horizontal approach and have the same servicer with the same ID, the same key, be deployed in different machines, handling traffic in parallel and writing to the same database the proofs for that work. and in the end submitting a singular having a singular source of truth for all the work that all the process performed.
Okay, so that allows one node to scale essentially horizontally. So you could have the same node running on multiple machines. And then what I guess the piece that I didn't understand is that there would be, it sounds like there would almost be like an automated or built in, I should say, load balancer. So it sends the calls to all the nodes with that identity versus just targeting one.
That's not, let's say, the Pocket process job to load balance. It's going to be an infrastructure solution. You put an Nginx load balancer in front, or an Apache load balancer, or any solution that you like, and that will already have the tools built in. You just have to point it to the set of nodes that are there, and there's multiple strategies, or even strategies based on latency and availability that will allow you to only push traffic to the nodes that are the most available, making your setup now very, very efficient in terms of latency response and things like that.
Okay, that makes a lot of sense. Got it. So it just opens up the door for those kind of network architectures where someone can load balance themselves. Got it. Okay. And then with that, because the database is being, is kind of separate, how quickly is it to spin up a new, would it be, do you think, to spin up a new instance kind of with the same identity, but not duplicating the database, obviously, because it's connected to the other database? Is that a pretty fast process, something that could, be very quickly automated?
Yes, that's the idea. That's the ideal that we're trying to strive for. Whenever you spin up a new instance of the process, it's going to be basically parse a file up. You don't have to do a lot of stuff. Maybe you do a few queries to the database to ensure that the database is up to date, it's not corrupted, everything is working, which is something that it will take only a few calls, then you're ready to go.
Yeah, truly amazing. Awesome.
Cool. Do we have any more questions
Thanks,
in the written channels?
No questions in the text channel. No hands currently raised. I know someone is typing, so we'll maybe let them finish typing and see if anyone raises their hand in the meantime. Okay, we have one question here. If I can have one stake node and I'm able to clone it to multiple nodes, how does that work in terms of DNS? Will all of them have the same DNS name?
Yes, that's the way it will work. If you are registered a particular DNS name for a node key, what's going to happen is that you have to configure all your traffic to land into a load balancer. And what this load balancer will do is take your traffic and basically run it or distribute it according to whatever rules you configure to all of your clone nodes, as you just call it.
Okay, more typing. Oh, and we've got a hand raised here, but I'll, in case that's a follow-up question, we'll wait until the typing's finished. No pressure. So some sort of load balancer would be needed to handle this, and that would be an external load balancer, correct?
If by external you mean that a load balancer that has a public IP, yes, that is exactly what it means. You will need a load balancer that has a public IP that on the other side serves as a proxy for your farm of node processes.
Okay, awesome. seems like that line of questioning is resolved. So I'll bring up Anaski onto the stage. I've invited you up. I think you might have to press something on top of your screen. I believe we now also have Twitter audio back. Anaski, I've invited you up to the stage. There should be a button at the top of your screen that you need to click accept to come up. There we go.
Yeah, thank you. Sorry.
No
Just
worries.
have a question about how you are managing read and write concurrency on this shared database, and how you can also manage sign-in blocks coming from different validators.
That's a great question, actually, and that is one of the that it's going to come up in further development. Right now, the main use case for this feature is servicers, because servicers are mostly going to be read besides writing out evidence of the work that they did as needed. So, for example, in the case of validators, this will be something that either in the first versions of V1 is not enabled, but later added as those concurrency trade-offs are resolved. In the case of full nodes, it's kind of the same, because every full node validates the incoming block and its transactions and replace it against the state. But in theory, you could have a design where multiple instances of the same full node could be processing parallel information as possible or as needed if we get to such a point. But ideally, the first use case for this replicated node setup will be for servicing, because those are at the state level, those will be read only for the state. They don't do any changes to the state.
Okay, thanks.
Thank you. I'll put you back to the audience now. Any other questions about the client-server architecture? We've got more typing. Oh, yep, one more question. How would these clone nodes be selected? Still the same way they are selected today?
So yeah, the thing here is that the network doesn't clone nodes you're running, because these nodes, as far as servicers go, these nodes are one node, one identity, which is what is outlined in the spec. As long as these nodes are one identity, the network will select servicers in the same way that it does today, because it will have all of those nodes will have a single entry point. So in that particular case, the network doesn't care about how many node processes you're running to service the load that is being assigned to that node key that you're running with. Now, if you're running multiple identities, then and then you're cloning each one of them, then it works exactly the same way. Each identity gets one entry point, and then within that entry point, you as a node runner get to decide how the by these different copies of the nodes.
There's a distinction to make between your processes and the account that they are working for. Much in the same way that you don't know what server is going to actually respond when you type an address on the web, and you don't really mind because you're asking for a specific website name. That's a good way to compare it to what's going to happen here. You're going to be registered. You're going to have a servicer registered, and the actual processes that you have running are representatives for that. Just as a server cluster you have of anything represents the service under one single name and not the specific IPs.
Okay, and then we follow up from that. If we are going back to the scoring aspect of V1, which we covered in the utility module Q&A, one poorly configured node then can impact all nodes, meaning if I have one copy that is poorly performing, wouldn't the fisherman score my identifier as a poorly performing node?
Yes, much like, again, it's just like today. It's if you have a fleet of 5 servers to serve a website, and one of those servers is misconfigured or wrong or whatever, when the load balancer tries to communicate with it, then the client is going to suffer. And also, because this, as Luis has mentioned before, this is the way that the web operates today. Basically, we're taking this technology or these solutions that apply to our case and bringing them here. That means that there's currently know-how on how to detect and deal with that, because as externally the network doesn't know how many servers you have. If uh, your load balancer detects one of your services is unresponsive, it can just stop giving it traffic and not affect your score in such a way.
So you're incentivized to make sure that your configuration doesn't impact the end user experience.
Yeah, and you also have to take into of 10 nodes to serve the traffic of one account, of one servicer account. On your That will mean that if you have one bad node, one lowly performing node, 9 out of 10 times that the fisherman sampled your node, they're gonna get a good service. So that means that you have to think about it as an average. Your overall average goes down, but it's not an absolute. It's not like you're depending on the sampling strategy of, it's not an absolute like, oh, I got one bad all the service doesn't matter. It's that 9 out of 10 times you did pretty good service that should net you a good overall score. And as Irving mentioned, then that will allow you to take action without having the absolute impact of having a single being the responsible for maintaining your good score.
We have another question here in the chat. Will Pocket support some kind of session affinity so that the correct instance in a load balance pool of servicers will get the traffic for a given relay session?
This is the beauty of having a client server architecture. Once the data of the session, the block data, and the state gets computed and written to the database, all nodes are going to have access to the same information. Now, there's the possibility of adding caching on top of the database that could cause some stale data scenarios. But again, we're in early days of development, and there are already known solutions to these kind of issues. So in the end, we won't need to create any special mechanism to share session data amongst the different instances, because they will all share it via sharing the same database.
Is there any other blockchain that is doing data in this kind of method? I know there's a lot of different chains out there. Just curious if this is inspired by any other ways that other chains have been have structured their data and how it's accessed.
To my knowledge, during the research that we did for the writing of the spec, I don't think other blockchain clients are doing this because remember, one thing that I think I outlined in the overview section, and it's the fact that blockchain clients are optimized to run as validators for the node, which means they think about liveness, but they don't think about high availability under traffic stress. So these kinds of techniques are mostly inspired by Web2 and my own experience in Web2 system scaling, and technology that it has been proven for decades now, that powers billions of users connecting to the same web application.
Do you have anything else you want to add there, Shane? Or nope? Okay. So we have someone else typing. If anyone has any other questions on this subject, remember the hand button is at the bottom of the screen. Okay, typing has stopped. And it started again. There we go. Without session affinity, wouldn't the traffic randomly be going to any node, depending on the selected load balancer algorithm?
That's correct. That is the intended effect. Because the session affinity happens
within the same session.
Yes, like your all your process. Imagine you have a node 1, 2, 3, and this node is paired with application ABC. Uh, and application ABC has 10 users that are different clients, all sending traffic to the same load balancer. It's up to the node runner how he wants to handle that traffic. You want to know something interesting that could happen with this approach is that now you could have multiple nodes in different locations and handle traffic that way. If you have a global DNS, for example, solution that redirects to a load balancer in a particular region close to the user so that your node gets best traffic. Of course, there's some implied latency because everyone will have to share the same database for this to work, but databases already have a streaming replication. So what that means is that the session affinity happens as soon as the data is written to the database and then replicated to any other horizontal streaming replicated replicas. It will be already in session affinity because we're all reading the same data.
So what you're saying is, in addition to us being able to have geozones to sort of partition service according to geolocation, we will also, services will be able to configure their own localization to maximize their quality of service. And they're incentivized to do so because of the utility module.
Yes, correct.
Holy moly.
Man, we're building V1 to be the default infrastructure provider. And this is the level that we see in Web today. So we have to elevate all of Web3 to that same standard.
Yep. Any other questions? Okay, we've got one more typing. Looks like we're going to be running over time here, guys, but we've got a lot of awesome ideas being discussed here. So if you want to stay on, I think we'll be staying on longer. Okay, no more questions there on that subject. So let's move on then to the next component, which I think was the tamper-proof hybrid mutable DB.
Yes, and specifically, we're gonna be talking persistence clientware middleware that makes it all that glues the application and the database engine together. Basically, what this part of the persistence module does is that it translates requests from the applications for data into queries that the database engine can understand. And when I say queries, I mean anything. Like it can be an API request for this, the sake of modularity. In this particular version of the spec, we're talking about using a SQL database engine. In this case, we're recommending Postgre. And what the client middleware will do is basically translate all these application requests into queries that the Postgre database engine is able to respond. But keep in mind that because this is modularized, you could in the future have even different database engine applications be available for users, so that people could plug and play and really benchmark their setup and use the database engine of their liking. A few things are required for this part of the module to work. You need something, for example, you need, in the case of SQL database, I don't know if you guys remember, but a few minutes ago, I was talking about how Pocket doesn't deal with the problems that Ethereum does where any user can upload any random bytes to the blockchain and expect the blockchain to interpret that and know how to run that. In this particular case, the Pocket state is actually a predefined schema. We know how a node looks, how an account looks. We know all of the data structures that are part of the state. So one of the things that this module needs to do is a schema definition. Basically, how does every data structure looks like? And then if we need to change data structures to accommodate new features in the future, how can you make the distinction between one version of the data structure and another? So in the spec, we outline a schema definition, a series of requirements and steps that can be taken to ensure a schema definition that will actually be tenable and maintainable in the future, right? Another thing that is important that has to do with the questions that were brought before and the client-server architecture is that you need idempotent writes and updates, meaning every time you write or update information to the database, you need to be able to do it in a fashion that if you get the same request again, you're going to have the same output and not duplicate data or some other unexpected side effect. And this is easily achieved by implementing a few rules that will allow the data to the data schema to know exactly when to actually read the data by crafting the write and update statements in an idempotent fashion. And then the other thing that you need is a deterministic write mechanism. And when we say deterministic, we mean when you write something to the database, depending on how you architect your application, you could have a level of like, oh, it's probable that that data was persisted correctly. But in the case of Pocket, and because we're required to maintain a specific state transitions, we need to stick to the ACID model, which means atomicity, consistency, isolation, and durability. This model has been battle tested through the years, and it's one of the industry practices that basically say, if I write to the database, I either get an error or I'm 100% sure that I wrote to the database. Or if something failed mid database write or update execution or deletion, this is going to fail in such a way that it's not going to corrupt the data that exists. There's a lot of documentation on ACID, so I will prime anyone interested in this aspect to check it out. because it's one of the things that it's even implemented at the database engine model. For example, in SQL databases, it's called a transaction. Basically, you can pack multiple writes, updates, and deletes into a single transaction and have it be like a mini program and say, if this part of the transaction fails, don't write anything or roll everything back or basically discard the entire transaction. So at that point in time, it allows us to have a high level of confidence in the data that is in the database at all points in time, even if it can be revalidated and checked for corruption via an independent process. These are a few things. These are things that are basically saying, hey, let's take all the best practices of these of having persistence middlewares and have the necessary attributes for our use case put together into this persistence client middleware.
Did you cover the tamper-proof part of it?
No, that's the next section.
Oh, okay. Okay, okay.
So let's give a to allow for questions.
Yep.
So yeah.
Any questions? Okay, I don't think we have any questions on that subject. The next piece is quite linked to it though, and is relevant to some questions that I have. So yeah, perhaps we can move on to that.
Awesome, yeah. So just to give a quick overview, so far we've described any good web application that is scalable, that is data secure, data integrity verified. You could take those two pieces, besides a few components like the ident and things like that, that are very pocket specific attributes, and say this is any web application. But the part that makes pocket is that it's a blockchain or that it needs blockchain data to operate, like in the case of the servicers, for example. So for that, you need an immutable data set that contains the state and the block data. So this immutable data set basically means that you need to create the blockchain data structure a data set in such a way that you allow for all the data that was written in the two sections before, all these block data, all of the state data, and you need to create it in such a way where first you need to produce the application hash, as it's called in Tendermint, which we're calling the state hash, and that state hash gets put in a block. And this state hash is basically one of the key components of a block that allows everyone to come into consensus that share the same state. So how are we going to go about this? So here's one curious attribute of our existing model. Right now, every time if you diff is a development term of taking two texts and basically looking at the difference. It's also a Git term. And you diff two heights of the state, you're gonna notice that they share the same data plus the delta, meaning the difference. What this does is that it creates a level data duplication that is not the most optimal for data retrieval. You guys, I don't know if you guys remember, but we talked about the death by 1,000 cuts that is adding a little bit of overhead to every scan and lookup operation whenever we want to query data or update data. So in this particular case, there's another side to that. It is very efficient to store these trees of data like that because the computation to compute the next state hash, which is needed for consensus, it's very easy and very achievable. So what we did was we separated it. Basically, we created in the spec, what it's outlined is that you have a mutable schema that is the operational schema on which people are gonna write to and read from. And then you have an immutable schema that is a representation using the same, in this case, we chose to use the Merkle-Patricia tries after doing research on them, using the same architecture that we're using today, just to be able to calculate and compute this state hash. This means that for an additional overhead of having a little bit more of storage space, now you could have a database that is very easy to read and write from, and that is also represented in this Merkle-Patricia tree style that will allow you to provide proof or compute the next state very, very easily. So what ends up happening is that you get a best of both worlds, and the trade-off is a little bit of a storage. But now you start to think, and you get to realize something. You could do actor-specific configurations here that will allow you to basically say, hey, maybe I want to run a pruned version of part of the database. So I'm never going to go archival and look so back into the past. Or maybe I can do a pruned version of the tree because for a state validation as a validator, I'm never going to go 1,000 blocks back. So keeping only a certain amount of heights is enough. We still don't know what these numbers are, but what this allows is to create several mix and match configurations that will optimize that storage space that we're sacrificing by having a database and a representation of the database at the same time. So in that representation of the database, we have all the same known, secure, and reliable mechanisms and attributes that make blockchain secure and immutable, while also leveraging all the technologies that make the web scalable today.
So there was a question yesterday about this specific feature, the tamper-proof hybrid mutable DB, and the word mutable sort of raised alarm bells for the person asking the question. That made them think that it makes Pocket more centralized. So just so I can make sure I understand what you just outlined there, are you saying that the operational processes and the configuration of the DB is what is the part that's mutable, and then the actual state data is immutable?
That is correct to an extent. Let me clarify. Today in Ethereum, in the Ethereum ecosystem, if you go and run a full node, you're not going to keep every version of the state. You're going to keep an agreed upon amount of these trees because going so back into the past, there's going to be data that that you're just not that node is not meant for. For that kind of data, you need to run an archival node. If you look at the difference in size, the full node is probably, it hasn't reached a terabyte, whereas the Ethereum node is a couple terabytes. So what ends up happening is that what we're doing here is that we're leveraging the fact that Pocket is already requires a pre-schematized database, and we're doing a database that is going to be written and read from, the one that is going to receive all the output. And also, this database will contain the state or a deduplicated version of the state. But the immutable part that is going to ensure that this representation of the database is actually secure, it's not being tampered, all of that will be contained in a series of Merkle trees right besides it, so you can basically run checks between the two. For Pocket archival nodes, you will maintain two versions of each. But the difference here is that even an archival node won't take as long to compute a response to an RPC query because it's going to be using a deduplicated schematized DB to answer those questions. But whenever you need to validate that state, it's going to rely on a series of Merkle-Pratisha trees that are going to be verifiable just the same way that they are being verifiable today. So the claim that this makes it more centralized could maybe imply that if you have a separate representation of the state data, you might need to rely on others to verify the state and things like this. But in the end, it's going to be a choice for every node runner, depending on the purpose of the node that they are running.
So the immutability property of the blockchain is focused on the Patricia Merkle trees, and then the rest of the DB
Yes,
is mutable.
Because the part that needs to be immutable is a subset of the data that the entire node needs to run. So we're going to make that part immutable by creating the set of trees necessary to prove the data, but we won't use that for anything else. We will only use it when necessary. Whereas in the design that we have today, we have to use it both for node operations, which means reading and writing data, and answering to RPC requests, validating blocks, serving relays. We're separating those into two, one best tool for each job.
In a way, it's quite analogous to how we do how we're doing a lot of other things in V1, in that it's optimistic. It's basically optimistic immutability of the data store.
Yeah, because your data store won't be less. Like, you won't have a functional state that can be queried unless you have the accompanying a set of trees to validate. So there will be routines inside of the app that will allow people to validate that integrity, and the application will know when it has and when its database has been tampered, which is the whole point of having this approach.
And there's something here in what you said. Actually, all immutability concerns in the world with regards to data are optimistic. You always have to assume things are okay, and then you check to confirm that it's okay. There's no way that you write data to a disk that makes it so that it's impossible to change it. The only thing that makes you know that it wasn't changed is being able to verify it later. So the format in which the data is stored only needs to maintain the mathematical properties that make it verifiable. And that's it. It doesn't matter if you're jotting it down in a piece of paper or a hard disk or in a specific type of database. Immutability concerns are always about verifiability that the data was as you expect it to be.
Makes sense. Thanks for that. Do we have any? Do you guys have anything else you wanted to add, or should we open the floor for questions?
No, I think we can open up the floor for questions.
Awesome. So yeah, we know the drill now. If you have a question, either click the hand on the bottom of your screen or type a message in the V1 research channel. No questions so far. Do we have anything on the Twitter side? Oh, Shane.
So is there I guess is there a place then with the separation of the data from the node? Is there a place then where, you know, there could potentially be services or something like that that pop up to be the, you know, database for your node or something like that? Is there a way that there would be like a commercial market that would essentially kind of rise out of this?
Would that not be simply the pocket relay chain? Or am I misunderstanding the question?
Can you reframe the question? No.
Yeah, so you have essentially these nodes, and then you have the data kind of in its own isolated or separate mechanism that the node accesses the data through this through like a call, right? So my question is there like a place here, or and I don't know if it's a good thing or bad thing, but is there a place here where there could be kind of like commercial storage of just the Pocket database, basically just that data layer, and then they allow you to have a node that has you can connect your node to it essentially.
That won't change. This only applies to the Pocket specific data, if I'm understanding your question.
Right. Yeah. I'm thinking specifically Pocket. So yeah, if you're wanting to spin up a node and you don't want to have to store the Pocket blockchain at all, there's a service out there, Pocket Stream, that allows you to connect your node to its database for Pocket.
That sounds a lot like specialty service providers, which could in theory exist. They would have to beat the collocations. They would have that, like there would be a few things, challenges. It's not like a straightforward, but theoretically, something like that would be possible.
Yeah, it would be possible, but may struggle to compete in the utility module paradigm where quality of service is being optimized and you have to minimize latency and so on.
Yep, that is correct.
Would you need to minimize latency between the Pocket node and the its data set?
Yes, correct.
Oh, okay.
The closer those are, the better. Usually, what we've seen in scaling web applications, them being in the same private network is enough, but the closest they are, the better. Now, you could argue that, okay, if the closest they are, the better, why not put it in the same machine? And in the same machine, why don't just do file system again? But we go back to the same question of scalability. How much can you scale up in a single machine versus having a more separated architecture?
Okay, so Fisherman will have a way to test if a Pocket node is closer to its own data.
I mean, no, it's gonna be apparent relay service, because if to service a relay, for example, I need to query the database to know if the application is in my session. The further away my node from the database, the longer that query is gonna last, which is gonna make my relay processing slower, and that's gonna make the servicer say, the fisherman say, node, whereas someone with a less distance between the two and appropriately configured infrastructure is going to get the best results possible.
Very cool. Okay, so the missing piece I was missing was the need for the node to be able to quickly access this data in its process of serving applications, and that latency would affect how it serves other nodes. Okay.
Yep.
Thanks, Shane. So we have someone typing, so we can wait for them. And yeah, any other questions? Okay, typing has stopped, and it's, oh, there we go. So in V1, 3 actors are important: servicers, validators, and fishermen. What is the strategy to make sure that the network is going to have enough for each actor to work efficiently? In terms of, what do you mean by have enough? Are we talking about incentives? Are we talking about resource requirements? Incentives. Yeah, so that's a utility module question. I can't remember whether we answered that question on the previous Q&A. But yeah, we have recorded that call, so you should be able to go back and watch that if you're interested in those kinds of topics. But yeah, each of the actors will have their own incentives that that the DAO will be able to calibrate. So that those can all be calibrated to make sure that we have enough of each actor, and that will be part of the governance of V1. No problem. Yep, and there's a link to V1 in the V1 research channel. Sorry, a link to the utility Q&A call. Also, we have some really great docs as well for all of these subjects. I'll link to the V1 overview. So we have, we have some really sort of, we've done our best to try and explain these concepts on all of these modules in an accessible way. So I would recommend starting with these explainers. I'll link to the persistence one now in the V1 research channel. And then if you follow the link at the bottom of this explainer, you'll be taken to the more detailed technical specifications of V1, and the technical specification for the persistence module is at this last link that I've just posted now. So if you've enjoyed listening to this Q&A and you want to read more about the specification, I recommend starting with the explainer to make sure you grasped everything, and then diving deeper into the technical specification there. We are also, this is not the only forum for Q&A. We do, part of V1 is opening up the R&D cycle to the community. That's our mission. So if you do have any other ideas or questions, any feedback after reading through the V1 specs, then feel free to share. We have this V1 research channel in Discord. We have a research category on the forum, and the V1 also has a GitHub repo that I will find the link to and post in Discord as well. Any other questions? Okay, so here's the in the link in the V1 research channel, I posted a link to the V1 GitHub repo. It's just simply Pocket. This is the repo where we are building out the V1 POC, and we'll be developing in there until the launch. And then we also have, let's see, the specifications are the technical specifications that I linked the Gitbook front end to. The back end to that is hosted here in GitHub, Pocket Network Protocol. So if you have any feedback on the documentation, you can submit GitHub issues there. So yeah, it doesn't look like we're going to have any more questions on V1 persistence. Nope. Okay. So one last thing I wanted to share before we all head off and enjoy our weekends is if you enjoyed this Q&A and you want to be able to chat more about the future of Pocket and discuss some really exciting, innovative ideas, then I recommend signing up to come to InfraCon. This is the first ever Pocket Network community conference that will be in May 20th to 21st in one of Pocket's homes in Dominican Republic in Punta Cana. So it's going to be an amazing couple of days of sunshine, pina coladas, and more discussions like this. And you'll get some face-to-face time with everyone working on the future of Pocket. So it'll be hopefully a more interactive experience, and we'll be able to all collaborate on V1 and everything else about Pocket. So yeah, sign up there. We will. There is unfortunately limited capacity because the Dominican Republic is an island, and I think we'd all be spilling out into the sea if everyone who wanted to come was able to. So we're going to have some selection. The core team will be inviting a group of people in the community who we really want to be there, who are long-standing core contributors. We'll also have a raffling system as well for anyone else who doesn't make that selection. So yeah, apply to the form in this website that I am posting to V1 Research Channel now. Sign up there, and yeah, we will have more information on the selections in the near future. And I can't wait to see you all there. So yeah, I think we can wrap it up there, unless you guys, Louise or Irving, have anything you want to add.
I want to thank everyone for taking the time to geek out with us about the future of Pocket. It's been really cool, and I loved every question. Thank you, guys.
Yeah, I really enjoy these, and I think after we do these initial Q&As, I hope that we can find an excuse to continue geeking out about V1. Thanks, everyone. Have a great weekend.
Thank you.